Hello and welcome. Today's video is going to be a rant. So if you don't want to watch it, you don't have to. It's just going to be because I've had some emails and about people asking why am I for this? Why am I just sticking to C for this year? I'm not going to C++. Why don't you just use a minimum subset of C++ or something like that and all that lot? And the long story short is I'm kind of going through in a moment at the moment, like thinking, what do I actually want from a language? And will C be good enough for me? Could C replace my needs for C++? And so far, my answer is yes. There are a few things in C++ which I would like. These things include operator overloading, function overloading, default arguments, and my ability to create my defer macro. So that means I would need move semantics, resource acquisition initialization, and a few of those things. But that's only so I can actually get defer to work. But that's my replacement for RAI in a sense. But apart from that, I don't really need anything else. I've thought about it, and also maybe the odd template for creating a generic thing. But as I've been programming in C, the only time I used for templates were for arrays and hash tables. That's about it. And maybe queues. Yeah, it's queues as well. But even then, I've been writing everything from C from scratch, and I've not been needing to dynamically allocate arrays or such, or dynamically hash tables and everything. So I haven't got to that point yet, at least. But even if I did, it wouldn't be hard to do, and it would only be a mild use case. So let's talk about C, the history of C and C++, and why I think C++ is a dreadful language, and why it actually shouldn't have ever existed in the first place. So C was invented by Dennis Ritchie and Ken Thompson in the 70s, and they were developing Unix at the time, the amazing operating system as it was, and where Linux kind of sprouted from it, and BSD and all that lot, yeah? And of course Mac OS X, or 10, or whatever you want to call it, is nowadays, which is technically just BSD with a different user interface and such. But yeah, that's what Mac is. So the question is, why was C created? So C was kind of like a symbiotic language. In a sense, it was created at the same time as Unix. As they were developing Unix, they were trying to do stuff in C. They were finding love and liking it. And if they didn't like, if they were missing features in C++, they would C, I should say, into Unix. They would add it into C. That's what they did. Because when they were developing Unix, they were trying to create a portable operating system, one that would work on multiple different types of computers. So C was kind of meant to be a portable assembly language. So because at the time, there wasn't one big operating system like there is now with like Windows and Mac and probably Linux. At the time, each computer had pretty much its own operating system. Every single computer had a different operating system, and it was a bit confusing because that means you'd have to write all the different assembly code for each computer, and what they just wanted to solve it by saying, okay, you write the same code and you can port it to a different computer. Done. There you go, you've got an assembly code language that is portable. A bit more high level and it's easier to read, but there you go. And that's what they did. They had a problem and they solved it. And C++ is still used today because it is one of the only literally one of the only languages out there that solves that problem still. I want a replacement for it because I want a higher level assembly language or something that's low level I have the control, but isn't as broken as C++ or has more features that I need for like metaprogramming and other features, but whatever. And also modern hardware as well, because C wasn't developed for modern hardware. But at the time, it was great, and I think it's one of the great languages in a sense. Now let's come to C++. So this was in the 80s. Bjorn Sustrup was developing C++, and he loved Simula, which is this object-oriented language. You may have never heard of it because not many people use it anymore, for numerous reasons actually. And he pretty much he liked C. He did like C, and he wanted Simula in C. He wanted C with classes. That's what he wanted, which is fine. So he added all that, and he got all of these class, and he added all of his member functions and all the other object-oriented things that were Simula-style object-oriented programming. Yeah? Because Simula was one of the first kind of object-oriented programming languages out there. And that was what it was for. So Simula had objects, and I think it was developed in the 60s, well, late 60s sometime. It had like these classes and objects. It had inheritance. It had subclasses, virtual inheritance and stuff. It had and also had, I think it had garbage collection as well. So that's what, I'm sorry, I'm going a bit sidetracked. So he was trying to add classes to C, which is fine. It wasn't trying to solve a problem though. His problem was made up, and he was just like, I wanted object-oriented programming in C, so I added it. And okay, it doesn't sound like anything like that, I'm sorry. But then over the years, people suggested to him, could you add this into the language? So yes, he added it to the language. And then he added that to the language, and other things that weren't even like relevant or like mutually exclusive, like completely different from one another, and wouldn't have helped the language. So C++ is a Frankenstein of a language. It still is, because of all the compatibility stuff it has to go through. And so that's kind of makes you think, why? And then over the years, he was, again, had all these stuff, and I think, why are you doing that? That's not a good way of doing it. People kept asking him. He says, no, it's fine. Just listen to me. They went, okay, whatever. And then after a while, he stopped adding extra features, add less features in, and he was just more publicising it. He was trying to advertise this language so that everybody was going to use it. He said, you've got to use my new language, guys. It's brilliant. It's much better than C. It's so much better. Everyone's got to go to it. Everyone's got to go to it. Come on, guys. Come on. You got to listen to me. It's brilliant. And he was actually, and it worked, weirdly enough. So most people nowadays, if they want lower level program, they do it in C++. Like almost games are programmed in C++, software applications, C++, and all that lot. And this is the problem. C++, again, this is the difference between C and C++, is that neither of them so C++ didn't solve a problem. C did. C was sorted out and it went into C a problem. But C++ never solved a problem in the first place. It actually just creates more problems because of its language. And that's where I'm getting annoyed. Because I'm like, okay, what are the benefits of C++? And do those benefits outweigh like the disadvantages of using C? So first I'm going to talk about the features in C++, which I don't even know why were they added to the language, and why I don't even use them. Or if I do use them, I use them minimally. And then I'm also next going to say what the good things about C++ are. Yeah, that's good. And then I'm going to see what would you add to C to make C a better language? Because the short answer is, I want a better language already. I want a better C. Not a better C++, like what Rust is trying to do. Honestly, Rust, fine. You sort out to be a problem. Your Rust's problem is they wanted a language which was secure with memory and all that lot. And I think they've done that. But I don't want that. I don't care about that sort of problem. I just wanted a high-level assembly language. Rust, you've actually had a problem and you've kind of solved it. So good on them. Go, I like Go. I do use it a bit as well. Go sort out a problem. Their problem was they needed a distributed service, a system, and a language that was simple enough that it was actually pretty much designed for idiots. So, and it was easy to read, and everyone could conform to the same thing. There's only virtually only one or two ways of doing something in a language, and I mean it was an good way of doing it as well. And that's why I like it, because it's done quite a lot of the influences from C. They said, okay, how could we make C better? And then add some of the object-oriented bits in there, a bit, not many, and also kind of take out the resource management, which is the bit, manual memory management. I can't even say the words. Manual memory management. I couldn't say the word today. It's 3 M's in a row. I'm not going to edit this out, but that's what they were trying to do. I wouldn't use it for games because of that garbage collection in there. So that's okay. These new languages are all kind of being like domain specific. They're all sorting to solve a problem, and they are doing that. But C++ never did that. So let's talk about things. You can see obviously what I'm going to talk about. So the first thing is exceptions. For those who don't know, exceptions is a way of handling errors in your program by letting something else handle them. And what I mean is you've got an error in your program, you throw an exception, and then this exception gets handled elsewhere in the code, maybe further up the stack, or in a different function or whatever, or in this try and catch statement or wherever. So it kind of says you've got some code here for handling your code, and then you've got the code for handling your errors in two separate places. And in my opinion, for handling errors is one, you shouldn't really, just don't have the errors in the first place is the first question. Like, is it really an error, or is it just a condition in your code? And like that's how you should be handling errors. It says, let's say I was opening a file, open file, has the file open? If not, try another file or something else. Else, if it's fine, carry on. Because there's, it's an error. It's not. That's what you're doing. You're just conditioning code, and that's how errors. If there are proper errors in your code, like for instance, you're on a network and you had some proper lost packets, or you were you got lost input on something else, and that's they're proper errors. Or you got corrupted hard drive. In fact, they're proper errors that you have to deal with. And maybe you just say, okay, screw it. I'm just going to set the program's just going to crash and say, sorry, we can't deal with it. That might be a good way to resolve it. Or maybe saying, user, could you fix this for us, please? Or I know this is not always good answers, but they are a way of solving stuff. Yeah. So then it kind of makes like, why did exceptions even get into the language? And the next reason was resource acquisition is initialization. So RAII. So if you know about structs and classes and all that lot, you got these constructors and destructors, these fancy things you add to the language. And they allow you to construct things when they get declared on the stack or whatever, or with new or whatever. And then once they leave scope, they come out of scope or they get deleted or whatever, the destructor gets called. This is also the reason I don't really like new and delete, but that is another argument for another day. I don't really want to talk about it today. I want to keep it short, even though this is already going on for 10 minutes. It's acquisition. So when you declare an object, it pretty much it's like a mini function that returns the type in a sense, or takes the type and just initializes it or allocates or whatever it does, which is another problem with them, but that's only a semi-problem in my opinion. Is that now the problem with this is talking about errors is if something goes wrong in the code, you can't return an error in a sense, because they can't return anything. So if I was like having this thing here, in a sense, so let's say struct thing, whatever, I'm doing this style now for now, and then I had my constructor, and then destructor, and then we had a thing t, and then the new style is that, isn't it? It just means construct it without copying. Yeah, that's fine. So what if something goes wrong when you're constructing it, like an error occurred? Then you're thinking, oh, okay. Well, the C style way of handling it would be you'd have a function. So you'd say init thing, and then you pass thing into there, yeah? There you go, initialize, and something goes wrong, you've got an error code, or you've got some enum error, I don't know, whatever, yeah? Whatever the thing is. So then some people say, okay, you just throw an exception to do that, and like, okay, you got to try, and no, I'm not going to do that. It's just stupid, in my opinion. So then the other question is, some people say, don't use a constructor for that, use a function. I'm like, then it kind of defeats the point of constructor, doesn't it? And then, okay, that's fine. So then some say, okay, yeah, but I do love using destructors, because at the end of scope, like for instance this, this means at the end of the scope with this curly brace here, this thing got destructed or whatever, the memory will be freed, whatever. That's good. But I'll show the way I would solve that is you don't even need that. You could have init thing, and then the thing I learned from Go and at D and other languages was you could say defer destroy thing. Like this. So then you don't need a constructor. This is already, I'm just going to do that because that's actually my syntax style for C++. You can say defer this. Yeah, defer the statement here till the end of scope. One, you could handle errors, and then in this thing here, you could have a big block, and you could handle your errors here as well. You've solved, you don't even need these anymore. There they go, gone. Because you could have int error equals that. Hey, it handles errors straight away. And that is kind of what I want. And actually the syntax I would rather have is that. But that's something else. I can't do that. But that's what I want. And you don't need those. This is more extendable. You can use it for many other things because you don't have to do it for constructing or destructing. You could do it for mutex as well. Like for instance, you've got a mutex M. You could say lock the mutex. Oh, I can't even type today, or ever in fact. And then at the end, you just say defer the unlocking of the mutex. Yeah? And then just carry on with your code. It's so simple. It's even more extendable. And it's more actually explicit, like saying, okay, I've created this thing. You could even do it for files and like, say if int error, you could say if error doesn't equal 0, then carry on with your code. It's so much better, in my opinion. And that's the thing. So the next rant is object-oriented programming. You can kind of guess what I don't really like object-oriented programming, well, especially C++'s implementation. And what I would prefer is more of a static duck typing if you were ever going to do object-oriented programming. So static duck typing means that a type, but it has some related functions, not methods or member functions, like has some functions that has these types in them, and then you would say, okay, these are the specifications for I can pass a parameter to a function. This is a better way of actually having templates in my opinion as well. You don't even need templates. So let's say you're having a function and it's a sorting function. So we say void, yeah? And then we're going to say sort. So the parameters it could take, this is not real C or C++, I'm making it up, is we're going to say we could have a comparable array. So you'd have in, so this is the in array, and then comparable, and then going to have a pointer to it, out array, this is complete made up, and then you just do that. Because the old C style way of doing it is you'd have like quicksort. I'm sorry, this is probably not correct either. I can't remember how quicksort even goes. I haven't used it in that long. I just make my own sorting algorithms. But yeah, so what you do is with quicksort, you've kind of got void star base, size and score t, the number of the stuff you've got in that set. How big is the actual big? How big is the thing? And then you've got some function here as you comparison function, whatever, yeah? And that's what you do. But with this thing, one, you'd have two arrays, and all you'd have to say is in your code, say it's compile time here, and you just say if in is always say is a comparable type. You could do that, or you could just say anything with a comparable thing must have these things. It must have like a comparison operator or comparison function. You could have like be able to swap things as well. That's what you need to do. And I know, sorry, I'm kind of ranting on, but this is more of a static duck typing. You could even do that static dispatch. You could even do a dynamic dispatch, which is normal duck typing, and so on and so forth. And that'd be a better way of doing object-oriented programming. But again, object-oriented programming is still a problem because it treats data as if it was code and says, okay, your data has to fit the code I've already written. That's what object-oriented programming is. While this implicit method is a bit better in that it implicitly rises. Like sometimes you'll have the same sort of functions on code and they would just naturally arise. So you might have the same kind of patterns occurring, and then this thing that would just, yeah, you know what? Instead of just having to do overloads all the time, I could just do this. And that would naturally occur. Not the other object-oriented programming doesn't actually naturally occur. The only times it does actually naturally occur is for file systems and probably allocators. But that's because file systems are object-oriented in nature virtually anyway. Modern file systems are at least. And allocators, I just want a vtable is all I want. I don't even have to use a vtable for allocators. I can just use enums, but it's simpler. That's my rant. So the next thing is C++11. Now C++11 allowed for move semantics, which is, if you've not seen them, it pretty much takes an R value reference and treats it as an L value one, or whatever. Not really, that's not true actually. Just you can pass R value references. So you can have func thing, and then you got another thing here, and there's your R value reference, yeah? Not an L value reference, which would be like that. So that's what they're doing. So that's fine, they've added it to the language. But the problem is it's just added to the language. It wasn't part of the language to begin with, and it's a bit of a Frankenstein. Rust solves this by saying everything is like that. All pointers are like this. They've all got ownership and all that silliness. No, it's not silly, sorry, it's not silly, but you know what I mean. It's got it by default. That's fine. But in C++, it's not by default. So when they've added it in, kind of like const, that's not by default, so it causes problems. That's the problem with C as well. But no, that's not the rant today. Is that it's just added language. It adds too much complexity. C++ is an extremely complex language. I do understand a lot about the language. I do know how to do a lot of the things in the language. So I'm very competent in C++. But virtually everyone who programs their own project, they'll keep to a subset. And everybody has their own different subset of C++. Yes, a different subset of C++, and that's the problem. And there's what your problem is. Is C++ is not consistent with C. Most people do have some basics, have subsets of it, but most people will be pretty similar in the style of code. It may be just different conventions they use, but it's the same kind of subset they use or set of features they use. So let's talk about the good things in C++, because I've talked about all the negative things and I've been ranting for about 20 minutes. I'm sorry this is going on for a long time. I want to explain it thoroughly and explain what I don't like about C++. I know a lot of people you cannot agree with me, which is my opinion. I don't care. So the good things is operator overloading is very good, and is very good for functions and such. So not for like math types and stuff. That's very good. So also function overloading is very good, like for math types, and sometimes that's good. Default arguments are very good. Namespaces are also good in my opinion. Main reason why with namespaces is sometimes you just want to make a library and you don't have any namespace collisions, thus the name of namespace, or you just want to group them as modules. Like this is the graphics module, everything goes in there, but I don't usually go any more than 1 or 2 levels of namespaces, 2 at the most. I mean, that is even bad after that. It's not boost crazy where you got boost, thingy-bob, then the thing. It's crazy. And trust me, look at boost if you want to see what namespaces go crazy. That sounds wrong, but namespaces go crazy. Oh, look at boost. I don't know what I'm doing here. But yeah, it goes crazy like that. But then, you see, that's what I want. And also other things as well, for instance, like lambda expressions or anonymous functions, whatever you want to call them. They're useful as well. Not, again, just added into language. They weren't part of the language. Not what I wanted. But they're useful in cases. Especially for when you're doing those sorting algorithms. When you pass in a function, you can just make one of your generic ones in line with the code. So what would I do to improve C? To make a C? Yes, C? You saw what the joke I made? This is ++, that means it's still C after you've read it. Well, this one improves it when you read it. Get it? It's a pre-increment and post-increment. Oh god, that's a bad joke. I'm so sorry. So what I'd do is first I'd add the things I'd like. I'd add, first thing to make a better C is I'd add function overloading, operator overloading, default arguments, and that's about it so far from C++. I don't think I'd add namespaces. I may do, but only basic namespaces, and they wouldn't do any namespace mangling either, but you probably would have to do it anyway, like no name mangling. And then what else is there? I'd also get rid of kind of the header files and make it into like modules or a package system with like versioning as well and all of that lot. This is still adding to C, and it would still look like C. You could still add this stuff. In fact, you can add a lot of this stuff as kind of creating your own like preprocessor and stuff. I'd also allow to do things at compile time. So I'd have macros, but I'd have scope-based macros. So there would be a macro within this scope. I'd also say, okay, I've got the code that I'm writing. Just run this at compile time. So you could say, like, you could have like another flag, say compile time, and then what is in the block? So if one printf. So at compile time, you would see hello being written, or you could generate some of the code from your actual code. So the macro system or the metaprogramming system would still be C code. It wouldn't be a different language. It wouldn't be just this metaprogram, which is technically a different language, or templates, which is completely a different language, and it's actually Turing complete, weirdly enough. So yeah. So that is what I have as a problem. And this is the thing, I want a better language, I just don't want, but you can't improve C nowadays. And also C has got some fundamental things wrong with it anyway. I won't discuss them, it's not the rant. But sorry, if you've been listening this long, wow, I hope you've had it sped up by like 1.5 times to get this quickly. And you may not agree with me, anything I've said. You may be saying, oh, this is stupid, you do whatever. That's fine. I just don't care. But it's just, I'm kind of going through a point where I'm saying, look, do I even need the features in C++? And I may at the end say, yes, I want these extra features. It does make my life easier and all that lot. But at the moment, not really. It is a bit annoying in places, and it is kind of a luxury to have some of the C++ features. But it's not needed. I know I don't need anything above Turing completeness, technically, but yeah. So the short answer is I want a better language, and the better language looks like, for me at least, is what Jonathan Blow's developing, which is JAI. It has all these again, the metaprogramming stuff is good. It actually able to look at the abstract syntax tree as you're compiling. The programmer is actually able to look at it and do something as it. So it's pretty amazing, and the features it has and also it's developed for modern hardware. Because none of the language, even low-level ones now, are developed for modern hardware with SIMD and threads and all that lot. It isn't. And this one is more designed for it. Like, you can do all the fancy stuff. Like, you can do this source, like SOA and AOS things, like just with a keyword. You can just get it, you know what I mean? It would be very easy to optimize for our modern software. So, thank you for listening to the rant, if you have been. And I probably won't be doing another one of these rants unless someone asks another question, which means I need to do another rant. But sorry about that. So, yeah. The next video I should be doing will be the introduction to C, which should be coming next week or maybe February. I haven't decided yet. I just need to record them and write them out. So that'll be my Intro to C course, where I'll be teaching people who've never learnt C before, or even a programming language before, and I'll teach them how to install a compiler, a text editor, use the command line, understand what C is, understand all the basics of how to do programming, why you want to do C, all that lot. I'll explain it as if you're a complete beginner in programming and just wanted to learn and understand how computers worked, and understand that you're writing code that the computer has to read, and you're not writing for a software platform. The platform you're writing for is the hardware. So that is what I want to do. And also, I don't want to teach any of the object-oriented programming. I want to teach that, look, programming is a tool to solve a problem. You're transforming data into other data by creating code. That's what you're doing. Yeah, simple enough. So see you then.